Hello all, today we are going to finish covering section 4.4, factoring quadratics. Instead of having a equal to 1, like we did previously, we now have a not equal to positive or negative 1. We have a way to solve this that I like to call the slip and slide and slip method. So instead of just doing a bunch of guessing and checking, we make the problem simpler to solve and then finish it out. So let's take a look at one. You'll notice our a value here is not equal to 1, so we need to do this slip and slide and slip method. So the first thing we have to do is we need to slip this 2 back. That means we need to multiply 2 times 12. So when we do that, that means we have x squared left up front, plus 11x, plus 24. So we've just simplified the problem so that we can solve like we solved the previous homework's problems. We need to find the factors of 24 that add to positive 11. So if we look at the factors of 24, we have 1 and 24. We have 2 and 12. We have 3 and 8. We have 4 and 6, and I believe that is all of them. Now, we just look and see which one of these groupings will add to positive 11, and we notice 3 and 8 will. So we can go ahead and put these in our parentheses set, x plus 3, x plus 8. Now we're not done yet because we haven't done our slide and slip back yet. So the slide step is just sliding this a value back underneath our 2 numbers. So we need to slide that under. If our numbers are reducible, reduce them. So we reduce 8 over 2 to 4. If they are not reducible, we need to slip one more time this 2 back in front of the x, and we are left with 2x plus 3. And that is actually our solution here. That is our factor. So if we were to go ahead and FOIL this out, first times first, outer times outer, inner times inner, and last times last, then we would see that this actually is equivalent to our original, just like yesterday's were. We just have this new method for when a is not equal to positive or negative 1. So we do the same thing on this next one. We go ahead and we slip this 4 back, and we say x squared minus 4x, and then this a times our c value becomes negative 12. We need factors of negative 12, or factors of 12 that subtract to negative 4. So the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So out of these, the only 2 that can subtract to negative 4 are 2 and 6. So we go ahead and put these in parentheses sets, and we say that 6 has to be negative and 2 must be positive. From here, so far we have found the factorization of this guy. Those 2 are equivalent. We want to find the factorization of this guy, which means we need to slide the 4 back under each of these. From here, reduce these. They're actually both reducible. We end up getting x, and then reduce 6 over 4 to 3 over 2. And x reduce 2 over 4 to 1 over 2. And then if you notice, we have a denominator left here. That just means that we need to flip these back up. So we then have, for our final solution, 2x minus 3, 2x plus 1. If we were to FOIL this one out as well, you'd notice that it was the same as our original. The other two problems work very similar. I'm going to speed these up a little bit. You can pause if you need to, stop and look at it. We multiply 2 back. We end up getting x squared minus 5x minus 24. We can go ahead and write out our factors. So the factors of 24 are up here, so we can just actually look up here. Once again, we need factors of 24 that subtract to negative 5. So we will actually use that same set of factors, but different signs. So x and 3 and x and 8, but we need to look at our signs. Because we're subtracting, one must be positive and one must be negative, and because we are going to negative 5, the 8 must be negative, the 3 must be positive. Then remember to slide the 2 back under, reduce if you can, and if you can't, slip the 2 back up, and we end up getting 2x plus 3 times the quantity x minus 4. That one was pretty quick. And then lastly, for this sort of problem, when a does not equal positive or negative 1, go ahead and slip this back. So we get x squared minus 13x plus 30. Let's write out the factors of 30. So we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. Is that all of them? Yes. All right. So you'll notice, if you are just taking a quick glance, actually 2 of these factors can go to 13. So we have to pay attention to our signs. We need factors of 30 that add to negative 13. That means they must both be positive or both be negative. So that eliminates 2 times 15 as a possible factor, because they would be subtracting. If this was a negative sign here, 2 and 15 would be our choices. So be very careful. Sometimes we have problems like these where 2 factors seem like they can work, but we really have to pay attention to those signs. So notice negative 3 times negative 10 is positive 30, and then negative 3 plus negative 10 is negative 13. Slip that 6 back under, or slide that 6 back under, because that's what originally was here. Go ahead and reduce the fractions if possible, which it is possible in this case. Oops, not 4, but 3. Because there are still denominators, slip those back in front, and we have our factored quadratic, and we're done. All right, now we do have 2 special cases. On this first one, you can either do the slip and slide method, or even on these ones, it's important to look to see if there's greatest common factors. Notice there wasn't a greatest common factor between any of these we could pull out because 11's odd. You can't divide a 4 out of 3, and you can't divide a 3 out of 4. You can't pull anything out of 5 with those choices. Same thing with 13. So there was no greatest common factors. If there is a greatest common factor, I would suggest using it, but there wasn't. In this case, though, if we look, we actually do have a greatest common factor. It is 4. We can divide all of these terms by 4, which means we can pull a 4 out front. We are left with x squared minus 6x plus 9. And we can go ahead and factor this like we did previously. Factors of 9 that add to negative 6. So the factors of 9 are 1 and 9, or 3 and 3 if they need to add to negative 6. We know they both must be negative, so we'll take x minus 3 and x minus 3, and don't forget to bring down this 4. Now, the reason this is a special case isn't necessarily because of its greatest common factor, but because the two parenthesis sets are actually repeated. So in this special case, all you have to do is go ahead and state it like this. It's basically saying like this was a y and a y, it would be y squared. You just take the parentheses squared and you have your solution here. So special cases like that, if the parentheses are the same, you can write them as a squared of themselves. And then our second special case is having to do with perfect squares. If you notice, both of these are perfect squares. So we have a formula, although the formula can be more confusing than just what we do. We want to go ahead and state two parenthesis sets. Each will have an x. You can take the square root of 25 and you get 5. The square root of x, you get x. And then the square root of 49 is 7. So basically that is just what each parenthesis set is going to be. But then the sign in between 5x and 7 in each of them is going to be opposite. So if you were to FOIL this out, first, outers, inners, last, you would end up getting 25x squared minus 35x plus 35x minus 49. So the reason why this is not included is because it cancels itself out. That's why one needs to be positive and one needs to be a negative solution. So our answer here for this special case with square roots like this is take the square root of each, and then one is positive and one is negative, and you're good to go. All right, go ahead and try the Math Excel. Have a great afternoon.